but all right. So without further ado, I'm here with Luis and Theo, both from Germany. As you know, I'm Thiago from Brazil. And we can move forward and not waste too much time. I think it's scroll. Oh, okay. So we have to do a summary of everything really fast. So you guys were paying attention, and you know, like there are a few problems in the scientific research that we have nowadays. Of course, they brought the papers here that we could cite, and we saw the problems of research outcomes, how they are becoming less disruptive. The ideas are harder to find. The productivity in research is and innovation is declining in most fields, and also with the fact that the complexity of knowledge continues to rise. So you need more investment, you need more people, you need more time to do the same amount of productivity that we had before in scientific research. And they bring us the change that HPC and AI can change in this. Maybe it's not put correctly here, but it's just an evidence of what was going on. The evidence in the papers that they brought, they had 5 million of evidence, so it must be a great opportunity to work with such an extent amount of data. And they were doing tracking the HPC and AI to measure the impact and their novelty. And from the impact is to compare the citation volume and novelty using the ex-ante indicators, also the LLM, to identify the words and the terms and the probability regression model that you guys saw to measure all of that. The results, of course, very simple. Impact for the impact side, in general, AI and HPC tend to have more citations. HPC alone has a higher impact when you compare it to only AI, but the real synergy, the real impact comes when you measure, when you merge AI and HPC together to generate higher impacts. And in some cases, the case of biochemistry and genetics, even getting like higher, 5 times higher the impact in citations. For the novelty part, if you look only for neither AI or HPC use in the top 1% of the novelties, 5%, they have 5% in that. In the AI, they rose a little bit for 7%, and HPC 8%. And again, the real synergy is when you come and combine both of them, and it got they quantified for 16% of a higher likelihood of bringing a novelty by using those terms. And but I think the great part of the paper and what most contributed, I think, is this last part about the inequality in computational resources, publications, and output in between the countries. And I think the idea, the insight of when investing in computer, like as a public policymaker, I don't know how to say policymaker in second year of EPOG Masters. This is the best insight. Please go on. I'll have to go quickly. Okay. But we thought that we needed more context with the first time we read the paper. All right. Aldo said, I'm not going to give this class again, but he gave this class only for major A. So maybe it's better for us to bring it a little bit. And the novelty in scientific research, to bring more context. So we bring what is the importance of the novelty, and are there other forms of measuring this novelty? And for the AI part, and how is their applications? What is considered AI, and the types of AI, and why LLMs are the most suited for these points. Please go on. So novelty in scientific research, we can see conceptually, of course, the impact is it advances the frontier of science. If you have a novelty, you can expand the things, you can bring innovation, and you can have more things to study about. So you can expand this frontier, and it's an important parameter for decision making. Let's say you are a fund manager, you want to invest in an institution that makes research. You want to use a parameter like novelty to measure which one of them you're gonna put in, you're gonna invest your money. But it's also mainly in history and social sciences, a socially constructed concept. We cannot measure it correctly, and this is why it's a big problem for us, which is a bit different than the STEAM fields. But we do also have some types of measurements for it. And please go on. And I bring here like the other types of measurements that we can make with the data that they had. For example, the text-related indicators. And so what are the other tools that they could have used? But these ones, of course, were fitting better. They used, for example, this the word combinator, new phrase, and word. This is the word combinator. So a new combination of phrases or a new word that was put out and it was considered as a novelty. But we could also bring, if it's a journal combination, so a rare combination of cited journals from different fields, you can use that as a novelty as well. What is it as a recombination of reference? So you look further, more granularly into the citations, not only the journals. There are other types, for example, the doc distance, which is the distance from extant papers, so how far from other papers you are. In the topics that they talk about, you're bringing something novel. And the disruption, the disruptiveness indicator is more of the expose part. So you look into more of a few years after you published something, you can look into the citations and see how well it went by. And the word reuse, for example, if the word you brought, which was a novelty, is being used in other papers as well, this could also be a form of novelty. And I'll have to go very quickly here in the definitions of different types of AI. So when we think about AI, we think about ChatGPT, first thing that comes to our mind. But this is actually just the last part of this Venn diagram. This is where it fits. Some people, like there are different types of people saying what AI actually is. Some people agree that, for example, artificial intelligence is everything which is not, you don't need more of a human input, something you used to do manually, you can put a machine to do it, and it can automate it for yourself, and this is called AI. So if you ever done an if-then in your Excel file, you're doing AI. You can put it on LinkedIn in your CV, so some people would agree on that. I wouldn't, but anyway. We have here in this Venn diagram machine learning, using the AI, I'll just go past by deep learning. Then we have generative AI, which we will look into images, video, large-scale pattern recognition, and, oh, sorry, this is deep learning. Generative AI, we can generate outputs without explicit instructions. And then it comes the LLMs, which are we can say is just a prediction model of when you give a prompt to it, a text to it, it was fed and trained by the data that it's going to predict the next word, and it keeps doing that and doing that and doing that, and you get your result from your ChatGPT. And anyway, this is more of a, just to give more context, and I'll have to go here and pass it to Luis.
Yeah, so as already mentioned, we need to rethink, we need to think about correlation and causality we have here. So I want to talk a little bit about causal inference. Causal inference describes that there's sometimes correlation, but not always causality. Here, for example, I have the funny example that the degrees awarded in social sciences correlate to the Google searches for dollar stores near me. I can assure you this is just a correlation and not actually a causality. So we need to have some type of prior knowledge of institutions to interpret the correlations we see and talk about the outcomes of interests we are looking at. So especially if we have observed data, we need this prior knowledge to justify the causality we are describing. And to move from here into a more philosophical perspective, in philosophy we would differentiate also between the explanation and the prediction that we have. So the really simplest relationship in philosophy you have is that you have a prediction and explanation that relate to each other. So let's look at causality in machine learning. I'm going into a broader sense here a little bit, but Thiago explained you like how these all are related to each other. So what is the causality and what is the relationship between explanation and prediction in machine learning? Machine learning has a type of semi-autonomy. That means that the machine will adjust itself in the data it is given. So there's a type of epistemic opacity, we would call it. That means we don't really know how exactly the process, how the predictions were made and the phenomena being researched looks like. Because if we have certain patterns in the data the machine is trained on, the machine will adjust to this, but we don't really know how it adjusted, and the data is very important like to look at also. So to make this more clear, a quote by Srečkovič, a philosopher in Frankfurt: machine learning models reach predictions without the theoretical backup that supplements the correlations found in the data with a potential causal interpretation. So, bottom line in machine learning, a lot of correlation, but the causality, questionable. Basics in science, inductive and deductive research. Inductive research means we try to construct a hypothesis from data here in the broadest terms. Deductive research would mean that we try to prove a hypothesis. We created, for example, a hypothesis from literature or real-world observations or our imagination, then we prove this and falsify this, for example. So when we look at AI and what I just explained with machine learning, we might consider that AI itself is more of an inductive research method where we come up with something, but we still need deductive research to actually find the causality. An interesting paper by Cheng et al. 2024 finds that large language models are very suitable to find inductive things, but they are super weak in deductive findings. And you also highlighted this shortly, that especially falsifiable hypotheses are very challenging for an AI. That's why you ask a complex prompt and not a yes or no question, but because an AI has problems with creating falsifiable deductive research. What does this mean for the future? I used the bifurcation theme you all kind of have on your degrees. We could imagine two different ideas, like Humphreys comes up with this idea and also Srečkovič tackles it. We could imagine a type of human-machine hybrid where our cognitive possibilities are transcended by the machine that can help us, like high-powered computing or even AI. We can find orientation in a wide field of things and predictions, and then we know where to go. The other option would be, I put like this picture, I hope some of you are young enough to know the Hitchhiker's Guide to the Galaxy, where the big robot gives the answer 42. So they need to find the causality still. We could imagine a machine that just gives the researchers some prediction, but we don't really know how. And we still have the desire for explanations. So let's step to reality here. There are some research in other fields, and for example in medicine we have a very prediction-focused science. We want to know if a drug works or not, first of all. And here machine learning could really help, and we could also have shifts for predictions to understand behavior and psychology, or we transcend cognitive possibilities in neuroscience, which in neuroscience would mean that we would have a turn again to inductive research. Then I did go back to the paper itself and showed this graphic we also seen before to maybe come up with a causality here. And my thing would be, we need extensive downstream research to find causalities for our prediction, and this will of course increase the citations, and that's why we also see like the large correlations between AI and high-powered computing, because there is a lot of extensive research done on these predictions made in AI usage papers, for example.
So yeah, of course, as we saw in the presentation before, a lot of this AI and high computing research was done in natural sciences. So, but we are in social sciences, and this is why we asked ourselves, okay, what are the impacts that for our science? So obviously, it could improve modeling, could improve or like discovery of previously invisible patterns, and this could obviously lead to the discovery of new research fields. But this comes with a number of problems. Yeah. So social data is inherently different than data in natural sciences, for example. So first of all, data is not neutral. It's heavily biased or can be heavily biased. For example, administrative data is subject to structural inequalities, or data that we scrape from social media is subject to the algorithms that decide what is visible. To improve the models, it would require to gather more data and more diverse data for overall. So the problem here is that it could lead to, or it requires the datafication of everything. This is a graphic from Zuzana Zuboff that she made in relation to large internet companies and how they use data to improve their predictions. This is called like the dynamic of prediction accumulation. Of behavioral surplus accumulation. So it starts with the behavior in the online world, then transcends to the physical world, and then it tries to gather information from everyday life and our body and ourself. So this obviously poses highly ethical questions. And yeah, this is not a trivial issue, and surveillance is a key problem here. No, go back. Yeah. Then there are more like epistemological questions that are posed by Dreyfus in 1972 already, and a lot of them still hold true today. Basically, he said that our social life is different to the natural sciences in a way that human behavior is subject to like our emotions, it's subject to culture and a lot of other things that are really difficult to quantify and to formalize, because this knowledge is tacit, and yeah, it's really not observable and understandable. So this creates a problem in that sense that AI can never acquire something like a common sense, which is very important to understand human behavior, and also in social sciences, obviously. Yeah. So yeah, there's a fundamental question with the future of AI, to get more like a view into the future. Which is basically, the question is if AI is like the ultimate invention of invention, since it affects our the thinking itself. So basically, it's a question: are we getting smarter, or are we getting smarter at getting smarter? So this is still a little bit uncertain, because it's yeah, still not sure if just maximizing data, like the free inputs of AI, data, parameters, and computing power, will lead to this kind of breakthrough where AI could like become qualitatively different. So it could pose like own research questions, for example. This has implications. Go back, please. This has implications because one would be like exponential growth of research and development, but the other one would mean that we would hit like a wall, and there would be diminishing returns in the end. So obviously, let's regard. It doesn't matter what the answer to this question is ultimately, but we know that it has a big impact. So let's see who will. So it really matters what the research is done for and what it's used for. So if we come back to the inequality question, here you can see the country's share of supercomputers, and here you see the share of the supercomputing power. So there the inequality is even larger, and you can see that the United States and China are obviously the two biggest players in the game, and this obviously has some geopolitical dimensions. And if you look historically, the development of AI was always really closely connected also to military research. So this is obviously of major importance, and yeah, just in general. Yeah, so this brings us to the question kind of, what is the role of science in society? don't worry, I will not answer this question now. It's a little bit too big, maybe. But what is safe to say is that we definitely require science to provide some fundamental reasoning for normative decision making, and also to solve the problems of our society. But the problem here is, of course, that this technology is basically controlled by states and private corporations, which could interfere with the independence of science, which is why Yevgeny Morozov, one of the, in my eyes, the most developed critiques of AI and technology, said that as long as AI remains largely under corporate control, placing our trust in this technology to solve big societal problems might as well mean placing our trust in the market. So basically, improving our modeling is only, will only bring us so far in society and will only have marginal impacts on improving our lives, as long as what we are trying to model is a capitalist economy. So this is why he also said that technology's emancipatory potential will only be secured through a radical political project. And he said that while he was pointing out to the CyberSyn project in Chile and its little brother in Argentina. So there's obviously a lot of room for expansion. Maybe two key takeaways are that the future is uncertain. We don't know what will happen with AI. Technology will not save us in that way. The problems are far more complex than this. And yeah, this leads us to our questions. I might just read them out quickly. So,
okay. So my question is, looking as a data analyst, that you guys have to do this kind of work as well, but with the critique, trying to expand your thoughts, like how would you measure the novelty in history and social sciences studies and also STEM sciences if you didn't have any data constraints? And how would be like the utopic way of measuring that? And just to try to, if you could expand from only tax-related premises, because I understand it's what we have in front of us right now, what we can work with. So yeah, it's a challenge to think about a little bit.
Yeah, I focus more on this machine learning extension it did, because you also yourself use like an LLM. If AI is an inductive research method, what does this imply for non-AI based research? Will we remain in deductive research to prove AI, and how does this feed back to downstream applications and to citation scores? So will there be these big predictive models that come up with a big correlation, and then you of course have a high citation score because there's thousands of researchers that need to somehow find the causality, and maybe also contextualize this in the inequality in the world.
yeah, my question is focused more on this meta level. So where do you think is this, does this scientific development with AI head to, and how can we contribute to equal accessibility and emancipatory use of these technologies?
Aldo. Yes, you can. Yeah. Aldo and Fazli, huh? Don't expect to be that quiet there.
Okay, thank you very much for the discussion. It was very interesting and thought-provoking. Let me start from the causality. While I do agree that we are trained, at least partially, to identify a causal relationship, is actually what differentiates economists from other social scientists. I also do think that that is a disease that is typical of economics. Physics, if you go and look at other fields, chemistry, medical, causality is not really the issue, I think. I think the issue there is to have a sufficient statistical robust model to say that a phenomena is like that. Of course, there is a theoretical physics, theoretical chemistry, in which we try to explain the world. But then when you go and look more to the applied part of these disciplines, they're far away from causality, I would argue. So I do think that your interpretation, that is quite right. I actually think that does apply quite well to a subset of IE models. And I may even provide you with some evidence of another example, in the sense that certain IE models are trying to do generalization based on data, and then there are other ones that are digging into the causality. It might be. There are certain general IE models that are there, and then they are subsequently improved, and therefore they're highly cited. If we go back to 2012, and you look at another tool, I wrote another paper on IE and the databases. So in image recognition, so you had to create a database of images to train your model, then to run it on another challenge. And those databases, actually, they were extremely important. So again, a tool that was used to achieve a specific goal, and those papers were extremely highly cited. So I think your causal versus correlational, inductive versus deductive analysis does apply within field. I am slightly less certain outside cross field. Okay, so what's the use of IE? Your argument is IE is highly cited. If I use an IE model in medicine on an HPC, it will be highly cited. That's okay. It might be. But we are working within the highly cited sample, and we show you that that thing is more novel. So I think there we have a discontinuity, so because you criticize the citation pattern, and we are aware of that, and so we subsample on the highly cited exactly for that reason. And the interest is novelty. Then it comes the criticism of novelty. How is measured novelty? What would be the ideal measure of novelty? God knows. That's the answer, Thiago. I really don't know. I know that all the indicators that have been developed till now, and we are speaking of about 15 to 20 indicators in the last 15 years, all of them have shortcomings. Some of them were based on references, so combination of citations in articles. Others they were based on combination of words, and the Shibayama took the text, the one you cite. There are a series of failed attempts too. Let me switch it to the policy discussion now, and stop whenever you want me, sorry. The UK has launched a competition to develop the best indicator of novelty. It's actually, well, I still call it the old way, DTI, how it's called now, I don't know. It's the Industry and Knowledge Ministry in the UK. So they put out money, a challenge. So the old way of financing science and technology. And actually the competition, if some of you wants to join in, the deadline is early January. And so they really have the idea that it's possible. They finance a huge project to then develop that indicator. That's a nice model, I think. They think that there is a possibility of developing the master indicator so that we can what? Better allocate research money. Why are these indicators useful? Why policy people are so excited by them? Not about philosophical discussion. They don't care. They need to allocate money. You are trained as a policy advisor, okay, or economic policy student. So in the UK, they have to assign money, and they assign money to science based on research council. ERC in Europe, whatever it's called in Germany. I don't speak German, so I can never remember. What is the federal agency in Germany that is financing research? Okay, exists a federal agency, trust me, that is financing research. In France, it's the ANR. in Italy is the ministry. So how do I assess to whom I'm giving the money? If I would be able to have the ideal indicator of novelty, then I would ex ante be able to allocate to the best project. Okay. I'm strongly against this approach. The characteristic of science is the per se unpredictability. If I'm able to tell you exactly what I'm going to deliver, that's not science, that's technology. It's applied research. I want breakthroughs. I want something that I did not know before. But I have to put public money. And if I don't put public, if I put too much public money there, I will put less public money in teaching. So they need a tool to better allocate and to better argue that that money is well spent. Okay? If you want to bring it to politics, we were discussing before at lunch, Trump has cut funding to US universities. As simple as that. Because of various reasons. But the way in which money are allocated are through peer review, analysis, and there are lots of problems there. And so these novelty indicators, they don't exist. So my answer is I don't know. And I don't think it's possible to do one, and there will be a lot of indicators. So to answer to the second, third comment, where did I put a piece of paper? So one was causality, the other one was novelty, and the third one was where I didn't take note. Can you go? There it is. What scientific heading to and how we can contribute? That's a good question. Again, I don't have a clue, but the paper tries to answer, to highlight that it's not only artificial intelligence. Alone is contributing in terms of citation and novelty a bit more than the average scientific field. Is combined with HPC, and that's the overall conclusion that I have added today and that was not in the paper. So I actually think that the leverage that we have, given the inequality that exists, that is driven by access to resources, is on the computing infrastructure. Okay, so accessibility, I mean, emancipatory use. I don't even understand what emancipatory use is. I mean, I understand, but it's very tricky. I'm a simple scientist that is measuring some phenomena. These big words, they usually scare me. So accessibility, inequality for me is more than enough as complex. Can we stop it? Because somehow a way is let's stop it. No, we can't. As you said, most of it is in the end of business, not all. Actually, there was an argument about 5-10 years ago that we had to invest much more in universities to try to counterbalance. But okay, public spending is not so strong. Actually, Trump went exactly the other way around. So is in the end of big companies. So how do we respond to that? Big companies will shape, is shaping. I mean, Hinton, that was a professor in Stanford, Hinton, LeCun, and Benjo are the three most important guys on development of deep learning. All of them ended up to work in companies. And then LeCun is still working in a company. The other two... okay, so good. All three of them pulled back out of companies. And they went back to the university or doing something else. But for 20 years, they were the leading figure in Facebook, in Google, and whatever is the third one. So the argument here is, I think that that part is gone. Okay, we don't control it. But you can control the infrastructure. You can network the infrastructure. Let me talk about Europe. That is what I know about. European model, what is the French AI model of artificial intelligence? Is the most successful one in Europe in any case. Mistral. The performance of Mistral compared to the other one, I don't know. Is worthwhile. Mistral is a company. Excellent. Yeah, it's French, so did you hear the excellent? It's excellent. I don't agree. I don't know. It's not a solution. I don't think it's a solution. I think we could network resources in Europe. This is all digital, it's all virtual. The best, largest high-performing computer is in Italy. And the Italians have stronger access than others. Yes, it's European finance, but it's not European. We should, first step, tomorrow, we should network all the HPCs in Europe, because it should be a common resource at the European level, instead of having national champions. I mean, that's a huge mistake that Europe has repeated in the last 30 years. It's not Europe. We are a bunch of defending our own champions. So if I have to advise, is and that is feasible, it's all digital. Okay? It's just a political stand that has to be taken. It's not easy. So I don't know if is IE, of course IE is important. But what the paper tries to argue that IE is not enough. Again, that development versus use, I think, is a bit lost, and it might be worthwhile thinking, because I think the development is lost for Europe and generalized to the rest of the world, while the use is not. So that I would attempt to ask to your very good and very broad questions that I can't answer. Thank you.
Okay.
Hello, thanks for the presentation, for your work, both presentations. I would like to know in the econometric... I'm Leo from Brazil. In the econometric model part, I would like to know how the AI plus HPC value applies to other fields, if you were able to divide work, because like Louis said, I think the impact of this in different fields of research is completely different. So if this would be the same amount of novelty, percentage of novelty in other fields. Also because I think the type of frontier thought that AI allows in STEM fields compared to humanities is completely different. And if you allow me a second question, it is, if you stumbled on the discussion of AI being used even before the research started, like in shaping the type of questions that we as scientists put to ourselves, or even if you want in a more practical sense, like using AI to gather results for a bunch of papers or data to choose to direct your research in a certain way, because I think it's not only about the amount of novelty, but also what novelty it is, like how AI shapes what we discover, not how much, not only how much we discover, but also what we discover.
Thank you for the presentations. I am Daniela from Colombia, and I have a question about something that you mentioned at the end of your presentation, saying that Europe and other countries should focus on hardware, and that is quite interesting to me because I think that it's even a harder field. It's competing not only with NVIDIA, but TSMC that is developing a 2 nanometer chip. I think it's a really hard field, and I would like to know why, because although taking into account that DeepMind it's actually was born in the UK, I would like to know why you consider that it's easier for these countries to be in hardware rather than software.
Hello, I'm Hannah from Austria, and you started by saying that you take more the innovation and growth models from Schumpeter, and since I was studying at Graz at the Schumpeterian Center, I wondered a bit also in sort of where we could take from the theory of Schumpeter some chances for countries which are technologically not as advanced as others and who don't have this use of HPCs or AIs, in the sense that couldn't it also be a sort of advantage in competitive senses that these high technological countries come or run into a sort of optimization trap, because they're more like what I understood in this Mark II model of these AIs are working as kind of super managers. These managers are not really, can deal not so good with unforeseen or black swans or this fundamental uncertainty, as we as the post-Keynesian always have to reinforce. And therefore the radical new innovation could actually come from countries with less advanced technologies, because what Daniela also referred to, that maybe that is actually the power, this that they could come up with something radical new. I'm not sure if I make myself clear.
Yeah, I'll take one more question and then I give you the mic back.
Hello, I'm Ben from India. It's a tradition. So I have a question from the impact evaluation that you have mentioned. So I have a question from the impact evaluation, the regression model. So in order to evaluate for the novelty, we looked into the new words that is being used in the paper. But how did we account for this? How did we find that this particular word is first time used in this particular paper? Asking this because, yeah, how did you account for the fact that it is used for the first time in this particular paper?
Then there is second turn. Huh? Leave time for the other question.
You're grilling me. Okay, let me start from the last one. Novelty indicator. That's the data from Arts and other. They took the body of previously published literature. How many years, Fazli? I don't know. Total corpus of Open Alex, and from when Open Alex has been publishing, registering, I don't know. 50s for sure. So that all the papers that have been published is been transformed in token, identified, and then a new token, new words have been identified. Clear? So it's the body of text that was available in Open Alex as full text. And then a new word came. Again, 5%. That was a technical question. Let me go back so that it's easier. Black Swan, innovation from Global South, variety, you fundamentally are telling me. Variety generation of new idea. In the Schumpeterian evolutionary approach, you have variety generation and selection. You are telling me there might be evidence of new science, new innovation. Please pay attention that for me science is very different from technology. Though IE is a techno-science, is hybrid. Yes, it's definitely true. On the other side, that is counterbalance on cumulativeness. That means science, less than technology, is cumulative, and therefore, where is more produced, there is a higher chance that will be produced more there, is human capital embedded. Okay? So where you have more scientists, there is a higher chance that the next push will come. The US has been extremely good in attracting talent. Okay? If you have one policy, suggestion, I mean, you are the failed, attempt of Europe competing with the US in attracting, look at the number in this room, okay? In attracting extra European. No, let me go full to the comment. It doesn't matter if it's filmed. Because you've been attracted here and you have a great experience. But then when you go on the labor market, gosh, if you're extra European, you have lots of problems, okay? Again, Europe, yeah. Ask to a lot of our researchers. No, okay. There is no. Okay, so I don't want her in labor regulation, but that would be a major issue. So attraction of talent has been the success. So pulling talent there. So it might be true, absolutely. But then I would argue in this way. Actually, IE, and I'm giving an example. I don't have the other computer. IE is HPCs. But IE is small data. CIFAR is a training data. It is one of the original, actually Hinton group has created CIFAR, okay? If Hinton tells something to someone in this room. Okay, they got the Nobel also for that database. And actually that database runs on a laptop. So there is a possibility of using some of the smaller tool of IE in context in which funding is lower. And that is a nice research question I wanted to address. So does this tool that costs much less, because it's not a big computer, it's a laptop, could increase productivity of less well-founded system? And remember the introduction, and then I stopped to talk so long of this talk. Science is money. And someone I can't remember has cited war. Science is war. Artificial intelligence, Ukrainian war, drones, okay? There has been a lot of demand for new, very, very advanced artificial intelligence models. But okay, guys, there is some misinformed innovation policies that speaks about mission as very vague idea. No, mission-oriented in the US has been military mission-oriented mostly. I'm not defending that, but I'm telling you that the story. In Italy, Galileo, Parabola, they were the fight among cities, the original start of science in Europe, because they used cannons to conquer the other city. So there is an interlink between science and military research. So demand, money. So yes, it's true that variety of countries, variety of, and then is constrained by the market, because of course you have to do science to invent and then you have to take to the market. But there might be a possibility that is worth to study for smaller IE systems that are running on lower computing capacity. HPC, lower inequality level. Let me see a face. I lost that question. Can you briefly tell me again? I just noted HPC, lower inequality level. Ah, yes. This was the answer. I got it. Sorry. Why HPC? I put these slides because of the graph of this morning somehow. And look HPC. In 2020, there were HPCs and they were used across countries. Okay, look here. In terms of small, in terms of flop has increased. Okay, but in terms of output, okay, has increased, but it's still lower. So there is lower inequality in terms of, take two technology, for me are two inputs. I mean, if production function, okay? IE and HPC are simply two input to a production function and the output is novelty. And the input of HPC is less unequal than the input of IE. That's why I would say there is more space for working. You look at in the last 7 years, this is top 1%, so we are talking of elite science. HPC is less. What is 2 is the double. So IE is the double of inequality compared to HPC. So again, I think Europe, the global south, is out of the competition for advanced IE models. But it could still play a game on HPC, and HPC might have, if you believe is not causal, between quotes, that there is some strong correlation between HPC and other scientific fields, then it might be useful. So it's not going to impact on IE, but it will impact on medicine. It will impact on economics, no, because they love causality. It will impact on environment, and so on and so forth. Quickly, the last one. We have a fixed effect by field. Somehow that's the answer, technical, but no, you're right. We need to segment and do a bit of subfield. A lot is in hard sciences, but it would be interesting to try to do natural science, social science, and humanities, so to do some field regression. Thank you very much.
Hello, I'm Florian from Germany. Thanks for the presentation. I have two questions, one on novelty and one on citations. So with the citations, my question would be, you find that with including AI and high-powered computer in a paper, you get more citations. But could this also be because... Okay, yeah, the other way around. At least it's correlated. Okay, so you find that in a top sample there's a higher amount of HPC in a paper. Do you think this could be correlated to some hype around HPC, because like citations are not, especially in the social sciences, necessarily an objective index of scientific breakthrough, but also of what is considered relevant, and this is not necessarily objective. And then the other question is about the novelty again. So in your first answer to the presentation questions, you said that you consider like the essence of scientific breakthrough to be that breakthrough is unpredictable somehow. So what is the sense of regressing on a novelty indicator in the end, if it's unpredictable anyways? Yeah.
Hello. I'm building up suspense. It's me. Hi. I have a really technical question. I care about this topic for my master thesis, and you are mainly talking about inequality within countries. And I wonder whether you have some data or some insights on whether the ownership of this supercomputing, so whether it's privately owned or public or a mix.
Hi, Alina from Argentina. I would not like to go to study to US, but it's okay. I understand the point. I have a question. So, sorry. In this policy, that is what? Okay. What should we aim for? You are saying that we should aim for putting money in having more HPC in this draft. And you are thinking this, I'm not even going to talk about Global South because I think we are I don't know. But do you think that Europe should try to equal US and China, or do you think that what should be the European scientific dream into this scientific world, to say in a way, related with this increasing inequality and in this context of concentration?
Hello. My name is. Sorry. My name is Jian from Peru. So I have two questions. First, for you and for the panel, Lois and the rest. The first is again for this concept of novelty. Maybe it's just taking a very uniform way of how science works, because I don't think maybe just novelty is the best the goal. I will say also there are maybe for example, replication crisis, and how papers are against other, and so to speak, have a battle between paradigms. For example, in economics or other sciences, there are conflicts between paradigms, and sometimes there are just not novelty. Also, there is a maybe dumb novelty, because you just keep insisting in a paradigm, and also maybe a replication crisis. Again, this concept that some papers are just revisited and then they are just proved wrong. And I would say this also maybe could take into account in an indicator how these dynamics maybe within sciences can work. And I don't know if you can you have addressed this problem in the past. And the second question is maybe more for the second presentation is maybe, I don't know why you didn't mention division of labor and this relation with AI and the capture of knowledge, because I would say this is like the concept that I think in the both presentation haven't talked about, and I think maybe if you see AI from a more social science, it's embedded in this division of labor and the abstraction of how this labor works and how is it distributed against the world, like from over the world. So I would say AI, I would take this stance that AI is just this abstraction of and mimic of algorithms and division of labor and within the society, and I think has natural consequences and has a power also consequences, and I would say this is maybe a scope that in both presentations haven't mentioned. Yeah, thank you.
Okay, next is you. Huh?
Yeah, it's all right. So the second was about novelty and why I measure novelty. In the first question, can you hear me? Yeah. The first question was about like citations as a measure of scientific breakthrough and whether there's a hype.
First of all, there are other indicators for breakthrough science that we don't use. Okay? So there is a debate there in the literature, what is the right indicator for breakthrough or what is the right indicator for novelty. We don't enter in that debate. Again, I think all indicators are wrong. You need to know what you are trying to capture with that, okay? Indicators is just a small part of it. So our way of approaching this problem is, what is frontier research? We think that is highly cited, so our sample, okay? This is the sample of highly cited. And then within this sample, our dependent variable is new. Okay, that's the way in which we try to approach. We focus on a specific set of papers that should, with a lot of limitations, capture impact in science. This is highly cited. And remember, this is total, I'm not explaining one paper. If you tell me one paper is highly cited, yes, there are lots of differences. Okay, this I take all the highly cited in each of the years, 7 years we consider, stratifying them by field and so on and so forth. So is a pretty decent proxy, then we can discuss more on this, of if a publication is acceptable as an output of science. So let's agree on this for the time being, then we can discuss also on that. And if top 1% is a decent approximation of impact, not quality. So I pay a lot of attention to these words of impact. It's been used by a lot of other scientists. Okay, it's telling you this, by really a lot of other scientists. Then this is our sample, and then we look at novelty. So if the science that has been used a lot by other sciences, within that science there is more or less novel science still. Because of your comments that you made. I mean, maybe highly cited is highly cited for some other reasons, but these highly cited, among these, there are also those that are extremely novel. So that was our attempt, and I rather prefer call it frontier, but frontier was the word used 30 years ago. Now it's more fashionable to use breakthrough science, but for me it's frontier, near to the frontier. That is the attempt of measuring that. Novelty, yes, you're right. I made a big mistake in all my paper. I mean, philosophically, you're right. Practically, I'm a poor applied economist. Okay, I'm very pragmatic. There is funding of research. There is a publication, and then I'm going to look within that publication. Okay, and then within that publication, I see novelty. So at the phase of funding, I don't want to look at prediction, because I believe that in that moment, we don't know exactly. I mean, there is a risk of financing too applied work, so I like to have a bit more variety there, okay? But then once I look at the output, so the publication, then I go and I look at the characteristic of that publication, and I do see that in some of that research, there is this novelty, and in some other not. A lot of basic research money is actually chucked out of the window. But that's good. I wrote a paper 25 years ago of unuseful science. Okay? We need to finance unuseful science, not useful science. Also, because we don't know that it's unuseful. So I finance that project, and maybe that project does not produce anything that is novel, it's part of the game. Then pay attention that novel indicator that has problem, that is a proxy, blah, blah, blah. But that's the construct. HPC ownership, Fazli help me, but yes, we can.
I can give an answer for Martina. When it comes to the numbers of supercomputers, more than 50% is concentrated within industry players, while for the flops, which was the computing capacity, it's close to 50% for academia and more than 50% actually. The combination of academia and research in this case can be government funded, it can be European Union funded, so it's public.
So yes, we are able to identify, and that's a good idea. We rerun the regression, splitting, and see if we have different effects. Europe, what is Europe aim in? Okay, so if you go, you know, because you follow my class, you know, 20 years ago there was the European paradigm. Europe is still good in physics and in chemistry, yes, but I don't know in which field. But causality, I don't know the causality now, but I accept that there is a correlation. That correlation tells me that this instrument is impacting across scientific fields, okay? So I don't want to pick fields, again, for that discussion, because I don't know what is the next biotech, I don't know what is the next artificial intelligence, I don't know what is the next mRNA, okay? But this is an instrument that could help research in a variety of fields. So that's the way in which I would answer to your question. Replication versus novelty. Did everyone want a Nobel Prize for replication? I'm nasty, sorry. Science is not a game for replication. It's a game to arrive first. If you arrive second, you don't count anything. It's a tough game, yeah, it's like this. Okay, and what I usually give is what is the text evolutionary, what's the name of the, no, 18 something, doesn't matter. Yeah, or the first book on evolutionary theory was published because there was a competitors that would have published. And now we remember the name of the one that published the first book and not the competitor. Darwin has published because the competitor, now I don't remember the name, Wallace, good, okay? Good, so we do kind in this class, but if you go out there, even in the museum, they don't know who Wallace is. So science is a winner-take-all market, is a rock star market, okay? Then replication is absolutely crucial as mechanisms to validate that we are not cheating. Because we are criticizing capitalism, okay, in this class, but science is much more than capitalism. It's really, really tough, okay? First one will win, that's it. The second one, but it matters for the reproduction. And then now I criticize myself. We give the prize to those three guys. We don't know what the team was. And that's a major problem we have in founding science because we believe that they are PI driven. However, if you take away the laboratory from the PI, maybe the PI is not producing so much. So it's not replication. Replication is simply an incentive mechanism for not cheating. Because we are human, we would cheat. And the increase of competition in science has been associated to increase cheating in science. So replication is extremely important, and that's why now we have a lot more replication compared to 30 years ago. But then what I think is interesting is the structure of production of science, so the laboratory. The second level, the third level players, they're actually extremely important, but they never get the prize. But without them, the first player would not get the prize. Science paradigm, yes and no. This fight, neoclassical versus heterodox, is religious group, okay? We are just fucking priests, sorry for fucking. It's like that. Economists are just sects. The two of them are looking at me like, wow, this is neoclassical guy. It always happens to me. When I go in a neoclassical department, they're looking at me, whoa, this is a bloody heterodox economist. Okay, sects. In other scientific fields, look at Kuhn, it's true that there are paradigms, and paradigms are competing, and actually artificial intelligence is a very good example, because if you go in the middle 90s, the deep learning, the neural network crowd was spread alone in various institutions and was minority. The dominant paradigm was another one. And then came to succeed in the 2012, and they suddenly thought, oh, wow, that thing works. Okay? But then there is realignment quite fast. Only in our field where is this 50 years that we are fighting each other. Like Catholics and Orthodox, Muslim, and so on and so forth. It's 2,000 years that are fighting each other. So no, humanities and social sciences are religious disciplines in which paradigms are extremely persistent. In hard sciences, medical sciences, paradigm exists, but then is the evolution, as Kuhn described in the 70s. That's it.
I will not share your last conclusion, because when you listen to some mathematicians talking about Bayesians like monsters or symbolic AI again, yeah.
Hi, my name is Marlene, I'm from Austria, and I have a bit of a more broader question about the labor market impacts of AI in the field of academia. And I want to ask about this because I think, like, for me, research is not just about the outcome and not just about like answering a research question, but also about the process of knowledge production within the researcher, and also their impacts then on civil society and their influence on policymaking that is really then changing the living reality of people. And I wonder about if especially young researchers are replaced more and more by AI. How do you think this affects the process of knowledge creation and also therefore civil society?
No, no.
Hi, I'm Jonas from Switzerland. I have a question that is somewhat related to because like they also in their presentation said, yeah, we could maybe use AI for modeling, and I would warn heavily against that, because I think specifically in economics, because I mean we construct models and we make them a lot more simple than reality, because we kind of try to afterwards look on the mechanism very much this deductive process. And I think then if you just I know that they now exist, right? But like those economic AI models, they're just a black box, and the question is like, what is the merit out of that? So I would be wondering if you see any purpose of doing that, or yeah, if it's just rubbish. And I have a second question, concerning scientific knowledge generation. Okay, sure. I can discuss with Louis afterwards, but I would like to know your opinion on that too. yeah. Yeah. And the second question is on that there's now more and more AI slop in science, so that many publications are complaining that just like also papers are papers journals journals are they have the problem that more and more articles are submitted that are just like not meeting any scientific standards, don't produce anything, just like are full of miscitations and so on. And I think also like archive and so on, like they sometimes stopped publishing stuff or self-publishing stuff because it was just flooded by that. So yeah, I would be wondering like, what is kind of your view on that? Where we're going there? Because I think that also kind of leads into that, right? What you've said before, that like science is this high competition and you need to get those citations and so on. So you just start publishing stuff, probably also with AI in the title to get on those citations and so on.
So I have my question too. I mean, you consider science and innovation is unpredictable, but you predict that we must invest in Europe on HPC. While a month ago, there was this article about tiny recursive model that, I mean, develop like LLM, but much more specialized, that can run on a single phone. So it means that in terms of AI, there can be breakthroughs, and you are just telling us that, okay. Thank you.
Okay, I keep yours last one. Let me go the other way around. I in the title. Actually, they have put, and there is a nice article on Nature, hidden text in the abstract of articles submitted to journals because reviewers, i.e. professors, don't have any more time to review, and they ask to AI of review it. And it was written, please be nice when you review this. Okay? So that the AI would have right prompt to be nice in reviewing that article. Yeah, we are in that game. And they got spot, and now journals have system to filter that. This is a, I can't say totally, but this is a very dirty game. Okay?
But it's the same for reviewers. I mean, one of the former Info students, he's doing a PhD, he got a review, and the reviewer forgot to withdraw.
But that is what I'm saying. No, the reviewer don't review any longer. They ask to the AI to review. And as we are kind of rational, then we tell to the AI reviewers to be nice with our article and get published. So yes, it's a dirty game. But I never said that science is a clean game. When competition is very tough, as in science, it's dirty. And then institutions are needed to control this kind of dirtiness that is going through. On the other side, I would have made much more money to enter in business. So there are survey of scientists, why we are in this business, and we can discuss about the strange interests that there are. But definitely scientists are responding to two sets of incentives, reputation, and so we need a Nobel, and they would do anything possible to do that, or getting a tenure, because a tenure system, and two, money. And so we respond in that way. We produce far too many articles, yes. That is, again, the incentive system of the last 30 years. But again, we could, through institutional, and now I'm serious, impact of that. Why do we count output? Why do we ask PhD students to publish already during the PhD? Because of signaling, yes, but it depends on the science. Okay, in economics is less common, in engineering and in physics and in medical research is more common. I don't know, but there has been literature out there arguing for a pressure of getting less output out there. Again, here we try to focus on the top 1% because of that, because there is a very long distribution with a lot of things that actually get zero citation. My first parameter, if is zero citation after a few years, sorry, you're a good scholar, but maybe you're not a scientist. And then, of course, if you are in economics, then if you are heterodox versus neoclassical, then you have that problem. But I'm speaking of science, not of religion. Okay, and so for me, science, even the real sciences are not sciences, because incentives are there. i.e. in economics. Who asked that question so that I look always, okay, I don't know any longer who has asked these questions. You have two broad approaches here. One is rational agents maximizing blah, 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 mathematical modeling, proof and theorem and proofs. And second, you have, of course, simulation, agent-based simulation that you have been studying. Agent-based simulation has been there, by the way, for 30 years. And now is more common, but we in innovation used it already 30 years ago. AI modeling is simply an evolution of agent-based. So the problem is not that it's a black box. Of course it's a black box. AI is more than agent-based, but within agent-based, you have the micro mechanism of the behavior. So as far as you go to the micro mechanism of the behavior, even in the AI-based, I don't know what is AI-based economics actually. I mean, it's used a lot in applied economics, okay? But in theoretical modeling, I would say much less. I don't know, maybe I'm obsolete, okay? So the point here, my answer is micro foundation are important because the micro foundation is where you take decision and where you decide if you use utility function, how you use it, if you use it or not. And so it's not the tool, again, these are tools. And you can use well or badly a tool. The tool, yes, is shaping, of course a tool is shaping where you can go. I mean, if you wanted to get a tenure in economics in the last 30 years, you had to use econometrics, full stop. Very difficult to get it somewhere in economics without using well econometrics. And that is constraining your way of looking because there are implicit assumptions in that kind of model. But as far as you use it knowing the implicit assumption, then it's a usable tool. It's up to you to become critical of the tool that you're using. Societies. AI is impacting social. Yes, AI is substituting scientists. Yeah, you ask me a lot of questions, so I need to answer them. AI is substituting scientists. I don't know, actually. Yes. Of course, I used to have more arrays. No, I didn't because I didn't have money. So I was producing less. So I don't know if substituting is increasing productivity. Measure as we measure in publication. It might have a substitution effect. Might be yes, might be no. There is evidence of computers that have combinatorial chemistry, actually, substituting people in the biotechnology revolution period, the 1990s, 2005. That said, science is there to have a social contribution. I mean, of course, I gave a presentation that is a production function, that I don't care about the output and everything. But again, most of us are in this business because we care of the social impact that we have, but the social impact is down the pipeline quite a bit. Again, I don't think it's the tool that will impact so much the outcome, but it's more the incentive systems. And therefore, the individual behavior of scientists that responds to incentives. The more scientists will be driven by salary, and this is labor economists actually that are pushing a lot of this, the more we will behave in a competitive way, producing as much output as possible, considering less the longer-term social impact. Again, AI is a tool for me. Is a new tool. Again, Galileo, the telescope, allowed to do certain observation, did not allow to do other observations. And has influenced physics? Yes, it has influenced physics in positive and negative way because the telescope was also used in war. Okay? And so it depends how you use the tool rather than. But it's the incentive infrastructure that influence behavior of individual scientists, and therefore the way in which, and the allocation of time they do in the simple production versus short-term versus long-term. I would argue in that direction. Science and technologies are two different things. Sorry, I would never mix them. Again, for incentives. I do not win the Nobel Prize. I will never win the Nobel Prize, of course. But I'm in competition for reputation, not for money. I'm a scientist, okay? If I had been a technologist, and I could have been partially only, I would have cared much more for money. So are two different worlds. And I'm saying HPC versus AI, because I think that it depends on the human capital, the development of science, and it might very well be true that the new, because David sent me this article that is very interesting, that the new possible approach is small scale versus large scale, i.e. models, but you still would need the people able to do that. You hire them, we have them, I don't know, maybe. If we do, it's even better. So when I'm saying HPC, I actually said HPC and human capital train in being able to use the frontier IE model. That is a pragmatic approach too, if we want for Europe and for the rest of the world. Because in that list of 59 countries, there is not only Europe, of course. There are a lot of other high mid-income countries that are trying to take decision and investing in these technologies. And so rather than trying to leap forward, I mean, yes, China did. China is amazing. I mean, it did, of course. Do we really want to be in China? I don't know. But this is a political discussion and is outside this framework. Okay?